Chapter 20, page 579, 580 in fact, 580, number 44. Make sure you've read the question before you go any further. As always, start by drawing a picture of what's been described. So we've got two long, straight, parallel wires. The distance between them, which we can call R or D, is 15 centimeters or 0.15 meters. Let's try and tidy that up a bit. 1.5 meters. Wire A and B. There's a current IA through A. Wire B in the same direction is 4 amps instead of 2 amps, so it's twice as much. So this one's 4 amps and this one's 2 amps. We're asked to determine the magnetic field due to A at B and the field due to B at A. Are they equal and opposite? Why or why not? And then to determine the forces. So the main concepts are the field due to a wire B is mu naught over 2 pi times the current divided by the distance between them, or the distance you are from the wire, and the force on a wire in a field. I'm not making it explicit, but this has to be wires that are carrying currents, otherwise there's no magnetism going on. And this is F equals BIL sine theta. And in this case, sine theta is going to be 1 because the angles are perpendicular. So I'm going to label 2 points. This is point X and point Y. My plan, I need to find the field due to B at X. I need to find the field due to wire A at Y. And I can already say straight off, because the current in B is twice the current in A, but the distances are the same, the field at X is due to B is going to be twice the field at B due to Y. Factor of 2, because of the factor of 2 in the current. Then I can use those two force fields that I found, these two values for B, BA and BB, plug them into here to find the force So the field due to B is going to be B sub B, and the field due to A is going to be B sub A. I can use BA to find the force on B, and I can use B sub B, the magnetic field due to B at X, to find the force on A. And then I can compare the two. But I can also say in advance that, remembering that the force that one wire exerts on another is proportional to the product of the currents and inversely proportional to the distance between them. This will come out in the algebra, which you're going to find that that the force is proportional to the current in A times the current in B divided by R at both locations, and so you're going to find the forces are the same magnitude even though the currents are different.